Hello viewers, in today's session we are going to discuss another important and conceptual problem from domain of functions, right? So here we have to find the domain of this function f of x, which is the sum of inverse trigonometric function and the square root function, right? So here f of x is equal to sine inverse x plus square root of x minus 1 over 2, right? So we have to find all the values of x for which this function f of x is defined, right? So let us start. So let us take this function as g of x, and let us take this function as h of x, right? So here f of x is the sum of g of x, which is sine inverse x, and h of x, which is square root of x minus half. So whenever we have a function which is described as a sum of two functions, then to find out the domain of that function, which is f of x, what we do, we find the domain of this function g of x. So let us denote the domain of g of x, which is sine inverse x, as d1, and let us denote the domain of h of x as d2, right? And let us take the domain of f of x as d. So the domain of f of x is given by the common values of x, which satisfies sine inverse x and square root of x minus half simultaneously, right? So first we'll do or we'll find out the domain of this function, then we find out the domain of this function, and then we'll take the intersection of these two domains, right? So this is the concept behind finding out the domain of a function which is expressed as a sum of two or more functions. So now from the inverse trigonometric functions, we know that sine inverse x, it belongs to the interval that is from minus pi by 2 to pi by 2, right? And whenever this x belongs to this interval that is minus 1 to 1, right? So the domain of sine inverse x is given by this interval, which can also be written like this: x is greater than or equal to minus 1 but less than or equal to 1, right? So d1 is given by this inequality, right? Now let us find out d2. Now here we have the square root function, and anything which is inside the square root function has to be positive or equal to 0, because here x minus half should be greater than or equal to 0, because we cannot have a negative number inside the square root sign. So in that case, the number does not belong to the set of real numbers, right? So for x minus half to be positive, it should be greater than or equal to 0. So we can take x greater than or equal to half, right? So d2 is given by this inequality, and this inequality can also be expressed like this: x belongs to the interval that is half to infinity. So once we get the domains d1 and d2, the next step is to represent these domains on the real number line, right? So let us take this real number line. Here we have minus infinity, here we have plus infinity, here we have minus 1, then 0 and 1, right? And this 1 over 2, that is half, it lies between 0 and 1, right? So here we have half. So now d1 is from minus 1 to 1. So here we have d1 and including both these endpoints, right? So this is our d1, and d2 is given by this interval, that is half to infinity. So here we have half is included here, and we go like this, right? So this is our d2 from half to plus infinity. Now we have to identify the common region which is lying between these two domains, that is d1 and d2. And from this representation, we can easily see that this region, that is from half to 1, right? So this part is common to both these domains, right? So d can now be written as from half to 1, right? So half is also included, and here 1 is also included, right? So the domain of this function f of x is given by this interval, and that is from half to 1, because this region is the only region which is common to both these domains, d1 and d2, right? Because this part that is from 1 to infinity is not included in d1, and similarly we can explain other regions also, right? So our required domain is given by this interval, which can also be written like this: x is greater than or equal to half but less than or equal to 1. Hello viewers, in today's session we are going to discuss another important problem from domain of functions. And here we have to find out the domain of this function f of x, which is equal to square root of x minus 2 plus 1 over x minus 3, right? So here f of x is given as a sum of two functions, right? So let us call this square root function as g of x, and this is a rational function, and we can call it as h of x, right? So f of x is the sum of square root function and a rational function. So in order to get the domain of this function f of x, what we will do, we'll first find out the domain of this function, that is square root of x minus 2. So let us call the domain of this function as d1, and then we'll find out the domain of this function, that is the rational function 1 over x minus 3, and let us call the domain of this function as d2. And then we'll find out, or we'll identify the common values of x which simultaneously satisfy this function f of x, and those common values of x are known as the domain of this function f of x, right? So let us call the domain of f of x as d. So d can be written as d1 intersection d2. So let us first individually find out the domain of the function x minus 2 and 1 over x minus 3. So now the function square root of x minus 2 is valid only when x minus 2 is either greater than 0 or equal to 0, right? So x minus 2 has to be positive or 0 in order to define this function g of x. Because if x minus 2 is negative, then this expression becomes a negative expression inside the square root sign, and in that case we'll get a complex number, and in that case the square root of a negative number does not belong to the set of real numbers, right? So for the validity of square root of x minus 2, this x minus 2 should be greater than or equal to 0. In other words, we can say that x should be greater than or equal to 2, right? So the domain of square root of x minus 2 is given by x greater than or equal to 2, which can also be written like this, that is 2 to infinity, right? So here this 2 is closed. It means 2 is included here. Now let us take up this rational function 1 over x minus 3, and here we are calling this as a rational function because a rational function is defined as the quotient of two polynomials, say p of x and q of x. So here one is p of x and x minus 3 is q of x, right? So the domain of this function is all real numbers except 3, because when we take x is equal to 3, then in the denominator we'll get 0, so this becomes 1 over 0, which is not defined, right? So the domain of this rational function is given by the set of all real numbers except 3, right? So now we have obtained the domain D1 and D2. So let us find out the intersection of D1 and D2 by making use of the concept of a real number line. So here we have the real number line, and this is minus infinity, and here we have plus infinity, right? So let us plot the points 2 and 3, and here we have 2 and here we have 3. So let us first represent D1. So D1 is from 2 to infinity. So we'll go like this. So this is the region which represents D1. So this is the domain D1, and remember here this 2 is included, right? Okay, now let us represent this domain D2. So D2 is R minus 3. So here we have the entire real number line, except here will not include 3, right? So first we'll go from minus infinity to 0, and then here we'll go from minus infinity to 3, and then from 3 to infinity. So this interval, or r minus 3, can also be written as minus infinity to 3 and union 3 to infinity, right? So here this circle signifies that 3 is not included, right? So here this 3 and this 3, they are not included. Okay, so now from D1 and D2, here we have D2, we have to now identify the common region, right? And from this real number line and the domains D1 and D2, we can easily identify the common region. So now the common region comprises of the interval that is from 2 to 3. First we'll go from this point, that is 2 to 3, right? 2 is included and 3 is not included, right? And this reason, that is minus infinity to 2, is not included in D1, right? So we'll leave it, and then we'll take this interval that is from 2 to 3. 2 is included and 3 is excluded, right? Because here 3 will make x minus 3 0, and 1 over 0 is not defined, right? And then we'll have here the union, and then we go from 3 to infinity. So then here we have the open interval. It implies that 3 is not included. So we'll go from 3 to infinity, right? So the intersection of D1 and D2 is given by the union of these two intervals, right? So we can also write this expression in a compact form, that is we can go straight away from 2 to infinity, and then we can write here a negative sign, and then we can exclude 3, right? Because 3 appears between 2 and infinity. So the domain of this function f of x is given by either this interval or this one.